Uh, with that, I'm going to turn it over to Mike Schmitz to discuss the future of Drupal multi-sites. Mike, it's all yours.
Thank you. Hello, everybody. Thanks for joining, and I'm super excited to talk a bit about multi-sites. Yeah, who am I? My name is Michael Schmidt, or people know me mostly as Schnitzel in the Drupal sphere and also in the wider internet world. I'm the head technology and founder of Amazee.io. What is Amazee.io? We do Drupal hosting. Actually, a bit more than Drupal just today, and we have a couple of specifically government customers, but also other customers that need to host a lot of sites. And together with them, yeah, we spent a lot of time thinking about the future of multi-sites because we think that how we do multi-sites right now might not actually be the best way anymore. So in my presentation today, I want to give a short overview to just bring everybody to the same level of multi-sites because there is a lot of different words for the same thing. Then we're going to look into what the solution today is for Drupal multi-sites and the issues of it. And then we're going to see how containers could be a good solution for that. We're going to talk about the case study that I worked on specifically, and we're going to have Q&A at the end. Unless there is a super crazy question that you need to know, you can definitely interrupt me, or you can keep it for the very end where I'm happy to answer any questions. All right, let's start with multi-sites. So what's the premise of multi-sites? What are they trying to solve? At the end, at one point in your life as a Drupal developer or as a government or as a company, whatever it might be, you might end up in running multiple Drupal sites. And you think to yourself, wouldn't it be really cool to run the same code base for them? But I still would like to have different databases, so different users, different content, things like that. And of course, with that, I also need a different file storage, meaning you don't share any files between them. And of course, each site also has its own domain, or maybe even multiple, but they are clearly separated. And if you look at this, you think, it would be really cool if for upgrades and security patches, if we could somehow only update one place and then it would automatically update all the other sites, that would be really cool. That would really help in maintaining. Maybe not if you have 2 sites, but let's assume you have 200 sites, or if you have 2,000 sites. Imagine updating 2,000 Git repositories. That would be very painful. And so that's where multi-sites were born. So it's mostly about easier management. One important thing, though, is that this is not domain access. So if you look into domain access, this is not actually a Drupal multi-site. You can, though, build a system with multiple sites. So let's look shortly into domain access because it's a bit a special thing in this whole world. Domain access system is actually a single Drupal installation, meaning you have one code base, you have one database and one file system. You also, you can have multiple domains that point to that single Drupal installation. And what you do at the end, you attach different Drupal entities. So like content, users, menu, you attach them to these domains. So you say for this domain, I want to have this menu. For this domain, I want to have this blog post, stuff like that. And what we see, though, this is only really usable for super specific use cases where this is what you want, where let's say you have a lot of content shared between a lot of different sites, and only some of them need to be different. Then domain access makes sense. But for today's topic, where we talk about multi-sites, we talk about sites that have separate databases and that have separate users. So let's look at what is Drupal's internal solution for multi-site. So Drupal inside, in core, has a functionality that you can have a so-called Drupal multi-site. That means you have shared core modules and themes. So these are folders that all the sites will automatically have the same core, all the modules available, and all the modules and all the themes available. Important is available. If they're actually enabled or not, is then dependent if the site itself enables the module. But the fact that they are there, that they are available in the module overview for a site to enable or not, is because they are in there. And then each individual site, so in this case we have site 1, site 2, site 3, each of them can have their own modules, themes, and files that they add on top of the existing modules and themes from the main core site. Also, each of these sites here will have their own database. And there is a file under sites. There's a file called sites.php where you actually assign different domains to your sites. So far, so good. Sounds like a really good system. Unfortunately, though, this system, when it was originally built, it wasn't actually really built in by the Drupal community for really massive environments. It was really more built for people that had like VPS hostings and things like that. And they wanted to run multiple domains or multiple Drupal sites under the same file folder. And what we've did as a Drupal community, we started using these multi-sites more and more and more and more. I've heard, or there are installations out there with thousands of sites that all use one multi-site. And they have quite some problems. So let's look at them. And I'm pretty sure some of the people in here know about them already. So let's see. The first issue is updates. So as we said, we have a shared core, modules, and themes, which is great. The problem is, though, because each of these sites have their own databases, you need to update the database sometimes. Like if you update Drupal, you need to run a drush updb. Or if you update a country module, you also need to do this because the database maybe changes. The problem is, because you update core and modules at the same time for all sites at the same time, you maybe run into an unstable situation because you cannot, or in some cases, you maybe cannot run drush updb at the same time for all these sites. And especially in the really big installations, you would actually overload the database server. If you run a drush updb for 100 or 200 sites at the same time, this would not work. So what happens instead? People came up with clever systems that only do some updates at some time. But that means that, let's say the site 3 gets updated at the very end, while the core, though, is already updated. Meaning this site will maybe have an unstable situation. This site is actually maybe down because the core that you updated expects another database column to exist, and so it throws errors. And so with 3 sites, that's maybe easy, but now imagine 200-300 sites. When you run like drush updb in batches of 10 or so, this can get very hairy. And I've myself been involved in upgrades, and they are super stressful. Like everybody hates the days where you need to update a Drupal multi-site because it can take very long. You never really know if it works and stuff like that. And so the problem is not only that this takes a long time, what happens if you realize that the site number 3 actually has an incompatibility? If you realize that there's such a big bug or such a big problem that now you need to roll back the core or one of the modules that you may be updated in there. And so you have 2 possibilities. Either you can roll back the core and the modules and the themes over here, but then you also need to update or roll back all the databases for all these sites as well, because now suddenly they have the old code again. And so the database has already been updated, so that's quite bad. Or you just accept the fact that your site 3 is currently broken and you have a team that tries to fix this in production. There is not really a way to have the site. Now there are ways, if you have a CDN and things like that, you can maybe still deliver the site while it is broken on the back end, but quite, again, this is super stressful for people. So one of the huge problems is that you cannot do individual updates. There is no way for you to say, okay, I only want to update site number 2, or I only want to update everything except site number 3. Or you can say, I want to try to upgrade all of them. If one of them fails, I only roll one of them back. And that's especially in big installations is a super big pain. Now you say, well, then let's just create dev sites for each of these sites. Then we can test them, right? Yes and no. So in this case, we have site 1 production and site 1 dev. we have site 2 production, and then site 2 dev, site 1 blah, blah, blah. So the problem is, though, that you still have a shared core. So there is no way to test a core update. You can maybe test modules update and things like that, but for any of the core stuff, there is still not really a way to do this. Now, another possibility would be that instead of creating in the same environment, have a prod dev, you actually create a completely second multi-site installation for all your dev sites. That is possible. Then you could update the core and you can update the modules and the themes and test them all on the dev sites. The problem is now you have dev sites for every single site, and maybe this is not maintained. The people behind this actually don't need this. You just create a lot of overhead. It's complex to maintain, and especially in big environments, this will be very cost intensive if you run every of your site a second time. So again, a possible solution, but quite a hard one, and one that in the actual wild is quite hard to use. So in the end, unfortunately, multi-sites don't really give us a very nice way to have development instances for every site or for the sites that we need them, that we can test any change before we actually run it out into the production environment. And now the last one, so far, we always talked about one Git repository. But in your case, maybe you don't want that everybody has access to every site. Maybe you have different teams that should have access to different sites, that they should not overwrite the code or the themes of another site. So usually what we do is we have Git repositories. But because the Drupal expects one site, it is one shared code base, how do you do this? There is a possibility with some clever Git merging and tree changes and things like that to actually have a main Git repository for everything and a Git repository per site. Now, this is a bit complex in how you merge stuff together and things like that. But the problem is, the biggest problem is that this Git repository here that only has the modules and themes and files, it's missing a core now altogether. So this is going to be very hard for any Drupal developer to do this. How do they then know which core it is? So what we've seen is that then people still check out the main repository and then the individual one, but then they have to commit in 2 different places. And honestly, that's a really big pain to run any of this in any good way. You end up with mismatched versions, it's confusing, whatever. And the last piece, especially if you then not only have different Git repositories, but if you want to actually access these sites, because all of it runs in one Drupal environment at the end, it's almost impossible to have individual access for drush. So if you want one developer to access only one site, let's say to run a drush cache clear on only one site, usually we use drush. But because it's all in one Git repository or in one folder structure, a developer, if they realize that there's another site there, they could just run a drush cache clear and another. And a lot of times what we see is that actually the actual developers that build the Drupal code, they don't have access to drush at all. What happens is that only a specific operations team has access to drush, and so they then need to run the drush commands and stuff like that. But yeah, that's, again, no real good solution. So we worked together with the Australian government, and they came to us and said, hey, we have around 300 sites, growing to 500-600 more, and this is a super pain for us. So we need to find a good solution. And we sat together with them and also some other customers, and we came up with a solution that solves all of these problems and actually brings a lot of more additional things. And this is all based around containers and the fact that container images can inherit their code from another container image. And I'm going to walk you through how this all works on a conceptual and also with some code examples. And we can also see that because we run individual containers, where each container is individually used for upgrade, security, and stuff like that. I just see Benji, you asked a question, can you use site aliases to use drush on specific sites? Yes, you can. The problem is, though, if you can guess the site alias of another site, you can just run drush commands in the other site. Like at the end, drush, all it does, it just tells Drupal, oh, I want to run my commands against the site 1 or run the commands against the site 2. But there's nothing that prevents you, even though that you are, let's say, the developer of site 1, that you just tell drush, oh, run my commands against drush site 2. There's no system in there that will prevent you from doing this. So you can make it easy for them, but technically, if these teams don't trust each other, let's say they're different agencies or different vendors, that's going to be very hard. All right, back to containers. So before we jump into the actual solution, I want to give everybody a short overview. How do we actually build Drupal sites with containers? Because not everybody is maybe aware of containers and how this all works, how container images work and stuff like that. So what we're first looking is as a regular container image workflow that you use for if you deploy any Drupal site, not specifically multi-sites, with containers. So it all starts with some kind of container images. In this case, we have specific Drupal container images. And what they do is they bring PHP and they bring the PHP config that is necessary for Drupal itself. All of this lives in a Git repository that is open source. It doesn't have to be, it can be open source, but basically that's where it is usable. So everything is in these container images that is needed to run Drupal in specific containers. Important though is that this does not actually contain any Drupal code. So it's only PHP and maybe some PHP modules and configuration and Nginx and stuff like that that is necessary, but not Drupal itself. This uses then the official Docker images, so for example, the PHP images that don't have any Drupal knowledge in them. And it's usually maintained and published by open source maintainers. So we are one, we publish all our Drupal container images, and we publish them, and they're usable by anybody. We have people that contribute to them. There are other companies that do the same, but basically that's not something that you really need to worry about. There are other people that do this for you. So let's look how this works. What you then do, you create your own Docker image or your own image. And the important piece here is the from. So instead of you installing PHP and PHP config and whatever else is necessary, you just tell your Docker, hey, use the other one that is over there. And now you then bring core modules, theme, your custom code, and whatever else needs to be necessary. So this is how you can use one image can inherit from the other one. And so this image then lives in your own site, Git repository. So this is separate. There are two repositories. They have individual maintainers, individual people, so you can just depend on the other ones. Now, how does such a repository actually look like? We usually have a Docker file, which is the recipe to build the containers, and we have a composer JSON. The Docker file itself just says from, in our case, Lagoon, with PHP, in this case, for example, PHP 7.2, the CLI Drupal version. That's just doesn't matter, you don't have to know, but there are different images with different presets and stuff like that. And then what you do, you copy your composer JSON in the composer lock, and you run a composer install. That's it. That's how you install Drupal. And then inside that composer JSON, you then define actually which Drupal core you want to install. In this case, we say, okay, we want 896. And then we also want to install Search API and Path Auto. That's how today we use Composer to install our Drupal dependencies. So basically, this Drupal container just uses an upstream, the ones we saw before. It brings Drupal core, Drupal modules, and themes with it, so that's fully customizable. And it's built during a deployment. So in our case, with our hosting solution called Lagoon, you just push this Git repository, and then Lagoon will automatically build it for you. It will build the Docker file. It will run the composer install for you and all that stuff. That's completely possible. That's all automated. You don't need to run this locally. So that's it. That's how today we can run Drupal code. And what happens at the end, the hosting platform, in our case Lagoon, will build a fully built container image So it will take the code from here, and during the building phase, it uses that. And this container image is then used to run your containers on clusters, Kubernetes servers, whatever else you might use to actually run your containers. So that's the regular process of building containers and using them. Yes. Elijah has a question. The Docker file seems like it needs a step to copy the custom modules. Yes, this actually happens here. So what you do here at the end is you just copy the whole rest of the whole Git repository into the app folder. And this is a little trick. Technically, you could copy the app in here already. But what we suggest is you only copy the composer JSON and the composer log, and then you run composer install, and then you run the rest. And the reason for that is it's a bit faster because the Docker layer caching is a bit more clever if you do it that way. But yes, all the themes and all your other files, your index PHP and whatever else, all is copied in here. No problem. All right. So we learned how all of this works. Now let's look at how can we use this system for a base image workflow. And now this is when I saw this the first time, when we realized this is possible, this was like this blew my mind experience. So let me show it to you. So we start with the same. We have our Drupal container images that we heard before. We have now our image that is called the base code. Instead of the site code, it's now the base code. The same thing so far. This runs in its own Git repository. Again, still the same. We have the workflow. It goes from top to bottom. And so if you look at the base code, it's same. It's still the same. We have CLI, we have the composer, we have composer install. So far you're saying like, what is different here? It's all the same here. So far, no difference. It's just a regular Drupal repository. It uses the images as upstream. It adds core and modules and themes. You can run this because it's like everything else. You can build a site from that. You can run it locally. You can test this automatically. The cool thing is you can push this image to a Docker registry for other people to use. So how does this work? It means that you tell your platform to the image that is the resulting image of all of this, you not only use this to create containers in the system, but you publish this image somewhere. There are container registries like Docker Hub, but there are also private ones. You take the resulting image and you publish that. And then other people can use that image and build their site from this. So this means you have a third Git repository where you have the site code, and this repository only brings the additional modules and themes that they want to add beside of the base image. But you can see, for example, the core is not part here anymore. So how does this look like? So the Docker file, instead of saying use Lagoon PHP, it says just the organization. So whichever organization, the base image you want to use. You then bring still a composer JSON and a composer log, and you run composer install, and you still copy your app so you can add your custom modules and all that stuff. And the composer JSON, instead of saying I define Drupal core version that, you also require the base image itself. So what happens in the background, that base image is not only published as an actual Docker image to Docker Hub, but it's also published, for example, as a composer package to, let's say, Packagist. And so you also require that specific base image. And then a developer can add additional paragraphs or additional modules. Like in this case, they can add paragraphs, time field, or whatever else they want to add. But they don't need to worry that the core and all the modules, the base modules, they're all part of this already. And because you use the from, and the core is actually already part of the image, so the code of the core is already there, what happens during this composer install, composer will resolve all the dependencies for this base image, and it will realize, oh, core is already installed with the correct version. I'm not even trying to download this anymore. So it's super fast because all that composer needs to do is just download the additional dependencies that have already been there. So to recap, we use the base image as an upstream. This is this here. We add any customized modules and themes via composer JSON. This is paragraphs time field, or any custom modules are added via this. We can all of this run locally. Even though our Git repository has no core in it, if we build this Docker image locally, we will have it at the end. So we will end up with a fully Drupal environment locally running. And then if the upstream changes, so let's say the base image is updated because they released a new PHP version or a new Drupal core version, all you do is you just rebuild all of this. Docker will automatically download the newest base image, and that's it. And at the end, it's the regular container workflow. Like there's nothing different than what we saw before. The first part is exactly the same. The third part is just another upstream, like we already had one before. So at the end, what happens is all of this will create a fully built container image that again can be used to run individual sites. And that's at the end, the underlying system that will solve all these three problems that we saw before. So let's see how this actually works. On the left side here, we have our Git repository for the container, for the Drupal images and for the base images. Together, this builds the base image. And from this, now, we can create as many sites that we want that all use this base image. So we can have the site 1, let's say this is the production environment. This brings a module and a theme. But we can also have a dev site. So we have a second environment which these two run in the same Git repository, but because the hosting platform can create multiple environments from the same Git repository, if you want a dev site, a staging, an acceptance, whatever, you just have a dev site. Again, brings the same modules and themes. Maybe you have the site 2, that one is only a production, you don't have a dev for that one, and it only brings a theme. The site number 3 is production. It actually doesn't do any changes because let's say your base image already comes with everything that you need. So you have core already. You have all the modules and the theme that you need as a site owner of site 3 is already there. So you don't even need anybody to change anything. You can just create a new site from that base image. It's the same color, like we don't change anything there. It's just a new site. And then you can have as many sites as you want. This can be different departments, different people, different Git repositories hosted on different Git environments. At the end, there is no real limit of what you could do and whatnot. So now, what actually happens if we want to do this for, if you want to update? So if we want to update any of this, there is a bit of workflow that we need to follow. So as first, what is going to happen? Some team updates the required pieces in the base code. So let's say you have one team that is responsible for managing all of this. And Drupal just released a new Drupal security release of Drupal core or stuff like that. And so what happens is somebody goes in there and updates the composer.json. And this composer.json will then tell the hosting platform to use a new Drupal core version. And as step 2, you then use this base image and you can fully test it because this is actually a fully runnable image that has everything in it. You can test your base code to make sure that Drupal still behaves as you expected. You can fully test it. You can test it locally. You can deploy it to an actual site. It really doesn't matter. You can do this wherever you like. And after all of this is done, and after you're happy with the base image, you push this then to the Docker Hub and the packages. and you run all of this in there. Elijah asks, are you going to? Yes, I will cover the database. So after that, what happens is you push the new base image. And that's the first step. That's the piece that you need to do to update. Now, what is really cool is you just need to redeploy these environments automatically. So what happens, in our case, let's say we do the 3A. In our case, we update all the dev sites first. In our little system, we only have one dev site, so we do that one first. So what we do is we tell our hosting environment or our hosting platform, update site 1 dev. And now what happens, because it rebuilds the container image for that site, during this build, it will automatically pull the new pushed base image down, which automatically comes with a new Drupal core. It will then add all the composer, the additional dependencies that you added, and it will build this whole thing, and it will create a whole site for it. So and then you can stop. You don't have to do anything on these other sites. If you don't redeploy this, you have one site updated, and you can test this individual site to make sure that this site still behaves correctly. If you have other dev sites, you could go update other dev sites, no problem. But you have time. These other sites here, because you did not redeploy them, there is no hurry. They are not down. They did not receive any new data or any new config or any code change. They're still running on the old system. And then when you're happy with the dev site, in this case, we update site 1 production and site 2 production. So we trigger 2 deployments for these 2 sites. And they will run, they will update, and you can test them again. You can make sure, okay, are these production sites good? If yes, then we go forward and we update site 3 productions. Now, this doesn't have any changes. This is going to be super fast, but it still needs to run a drush DB and stuff like that. And then we can go from there. We have site and whatever else site. So you can create your own schedule to update your sites individually in the order you want. Maybe you have some super important sites that need to be updated first because it's a security issue, or you maybe have sites that cannot be updated on a specific time because you want to wait on the evening or things like that. So that's basically how we see, with updating each of them individually, how you can define the schedule and make sure. And now the question is, how do we know that we updated all of them? Because if you can trigger them individually, how does it know? And that's something where our hosting platform, or some hosting platforms as well, they give you an overview of, for example, which Drupal version and every core or every contrib version of every module is installed. And you can actually query that. So you could have an overview of a dashboard that shows you which site has which version installed. So you can track that every of your sites actually have the newest Drupal core installed and things like that. So you use these kind of dashboards and queryability to the platform to actually in that. And so to the question of Elijah before, so how does this actually work? So each of these sites are completely separate containers, and each of them have completely separate databases and completely separate file systems. So each of these sites, there will be a database for this site, there will be a database for this environment, for this, for this, for this. Now, if you really want to, you could technically have shared. There are systems that people, for example, share the user tables. I mean, that's all then hacking on Drupal around. That's all possible. But the idea is that each of them have their own databases and their own files. In our case of the platform, happens all via auto provisioning. So you don't actually have to go in and create a new new database or so. That happens fully automatically because every of these environments automatically request a database. And the other thing is, each of them have, because they're running inside individual containers, you have individual permission for each of them. So in the container world, you can actually remote shell into a container to run things like drush cache clear, or you want to run an drush ULI and whatever. So because each of them are completely separate environments, you can assign users for these specific environments. So you can say, Elijah is the developer for site 1 and site 2, and Michael is the developer for site 3 and site 4. And we only can access these individual environments because every time that I go to the platform and say I would like a remote shell into the site 3, there's a system that can check, and because this is a separate container, the platform can actually decide, yes, Michael, you can access it, or no, Elisha, you cannot. So these are at the end, from a container point of view, these are completely separate environments that have no overlap or no shared and things like that. And also, if somebody would go in, and let's imagine somebody runs a drush SQL drop or removes all files for the site 1, they only delete the database. And because these are separate containers, the site 1 and site 2, they can never access each other. Because if you're remote shell into one site, you only have access to that one site. You don't have access to all the other databases, things like that. So what are the advantages of this? Well, first of all, we heard every site has its own Git repository, its own containers, and can have its own environments. If one fails, there is no single impact in the others. Permissions and drush access is given to individual sites, so you can make sure that nobody can access their individual stuff. But we still have centrally core managed modules and themes. So, and it's fully testable. So before you release a new base image, you can change them. You can have different versions of base images. We, for example, have a beta version that is maybe released a couple of days before for people to test if they want to. You can go, you can have them semantic versions, whatever you want to do. But it's still centrally managed. You can have multiple environments per site. So like we saw before, some sites can have staging and stuff like that. Plus, local development is super easy because at the end, you run the exact same everywhere. You just run Docker build and you run the containers locally, and they will have all the dependencies and everything is in there. So let's look at how this is used. I mentioned before, one of the first customers that we built that for was a couple of years ago for the Australian government. The Australian government has a project called GovCMS. And basically what GovCMS is a centralized hosting solution for all of the Australian government. So we run around 350 sites, and 300 of these sites all are based on a base image system. Each of these 300 sites actually have their own Git repositories. What they can do, they can bring additional themes. They cannot bring additional modules. All they can do is they can bring additional themes. That was a decision from their side, but this can be decided how much each of these site repositories can do with the Drupal site. You can define, you as the maintainer of the whole system, you can define all of this. And each site has a development and a staging environment. So if somebody wants to update their theme, they just push the Git repository in their dev environment, and then the system will automatically deploy the site. It will take the base image that doesn't have changed. So they can, within their environment, they can deploy as many times as they want. They can actually create new environments if they want to, stuff like that. But then if there is a production site, or sorry, if the base image needs to be updated, let's say Drupal core update, security releases, and whatever, there's a dedicated team that updates the base image, tests the base image, they have fully automated tests, and then they trigger a system that automatically updates all 300 sites in a batch. So they don't go 300 at the same time, because again, this would overload the database, but they can trigger, in our case, it's an Ansible script that automatically, but there's also other ways. And all they do is they click there and say, deploy all Drupal 7 sites which are using this base image, go. And automatically, this will run fully through, and it's fully automated. And all the team needs to do is just monitor. So they can see every site that has been updated. If they realize that, let's say, the first 5 sites and all 5 sites fail, they can stop the rollout and they don't deploy or they don't update any of the 295 others. Or a lot of times it's just of the 300 sites, maybe 1 or 2 fail. But again, because it's a container system, the site is actually not down. They can go in there and they can fix the sites themselves. So this reduced the stress from before where these updates were really hard. It was definitely, it's a much better system. So conclusions. Yay, multi-site installation now with base images are a super breeze. Of the teams that I worked with that we moved that into, they definitely started to like multi-site installations before, again, while before they were hard. Like people somehow were always sick on the day that sites were updated. The deployments are not stressful anymore. There is every time you can roll back all the sites if you want to. There's no problem anymore. We have individual permissions for each of the sites. And one thing I didn't mention so far, none of this has anything to do with Drupal. You can do this for Symfony. You can do this for Laravel. You can do this for NPM node-based systems. It's exactly the same because all we depend on is a Docker file that loads from each other. And as long as you have a package manager like NPM or Yarn or Composer, you can do all of this with any other system than just Drupal. And that's actually where we see that the world is going, that people are using more and more than just Drupal. And they use this base image system for all of them because they realize having it centrally managed is much easier. So we see that agencies that run 200-300 sites for different customers, they also use base images because they say we have one security team that updates the base images. We see people doing the same for like Node.js. So they have a centrally managed where they can manage all their Express.js and stuff like that. At the end, this is really usable for anything. So I know this is a lot of info in a super short amount of time, and it's quite complex. So we have demo environments. If you're interested to see any of this actually running, we have demo environments. It takes us a bit to set them up, but I'm happy to do all of this because I just killed the presentation. Because we definitely want to have people to play with this and to see this all happening. Because I only think when you actually have seen this one before, you can really see the powerfulness of such a system actually running and when you can play with it. All right, that's it. I saw there's a lot of discussion in the chat, and sorry, I couldn't follow in real time, so I'm opening the chat now, and I'm asking for some, and I'm looking at the questions, or if somebody wants to unmute and actually ask the question, that is maybe easier for me than reading it.
There was some discussion in the chat. Hey, this is James Sansbury. Thanks for the presentation. This is awesome. Exciting to learn about it. There was some discussion in the chat around Composer dependencies and how that works across these different Docker dependencies. So you kind of like have the Docker inheritance and then how the Composer dependencies work, but in both directions. So like you have modules down in the base image, and then maybe you have modules on site one. What happens when, you know, maybe like Composer has to manage dependencies in both directions up and down that inheritance chain of Docker?
So in the end, the fact that, I mean, maybe to get a bit bigger, technically, you could build all of this without Docker. So at the end, what we really rely on is a Composer dependency system. So that the fact that you can publish your own package with specific core modules and Drupal core in it, and then you can publish this package, And then somebody else can use, instead of defining the same dependencies, they can just depend on, like here, the base image package. And then Composer will resolve all of them. That, in the end, is the underlying system that uses all of this. The cool thing is with adding all of it in Docker is it is much, much faster, because you can pull in Docker image that has all the dependencies already resolved. So Composer will be much faster. A bit of problem today where Composer can take much longer. Plus also, in this Docker file, there is so much more dependencies that are also coming with it. For example, PHP dependencies. So Composer itself doesn't install PHP. So how can you make sure if the base image actually updates a specific version of PHP? You also get this down. So, but in the end, we run a Composer install inside the site image. So in this here, at the very end, we run a Composer install, and Composer needs to resolve all the dependencies. So yes, it can technically happen that if, I don't know, the Drupal paragraphs has a dependency on something that is not resolved in the base image core version, or they're conflicting, yes, this still can happen. But I don't think this is a problem of the base image. That's just a problem of dependency management in general. The good thing is, though, if that happens, is only this specific site will be broken, quote unquote. And because this actually happens during the building process of the container image, the site that runs is actually not touched at all. Because the containers that are running containers, they're only replaced after the Docker build is fully completed. And in this case, it would fail on the Docker build process. You could then go in and fix these specific issues. Does that answer the question?
Okay. We are just about out of time. Michael, is there will you be available afterwards to take questions?
Yes, I'm in the Slack of GovCon. I'm happy to answer any questions there. And also, Flora, could you please explain the concept of containers? Yes, I assumed a bit that people know what a container is. I do have some webinars that explain what a container exactly does and how this works. So I will post some links to other presentations that I've given about containers, because it's a bit too big, unfortunately, to explain this in a minute.
Okay.
Yes.
Okay. Thank you, Michael. That
Very welcome.
Kind of inception level stuff for me, but
oh, we could go much further. We could go much further.
That's what I'm afraid of.
you can add another Docker file and another Docker file if you want to. So yeah.
So thank you everyone for attending.